Okay, so this question's kind of a pain in the butt. Because the only real way to do it is to try and get like each individual equation into the slope intercept form. Because once you have it in this form, it's much easier to tell what the graph's going to look like. So this first question, it's not too difficult. If I look at equation A, I'm just going to start by subtracting 2x. So this equation becomes y is less than or equal to 2x plus, oops, sorry, subtracting 2x. This is y is less than or equal to negative 2x plus 1. So this would be an equation where the line goes through the point 0, comma 1 and has a slope of negative 2. If I look at the three graphs provided, this graph goes through 0, 1 and has a slope of negative 2. So now the only trick here is this shading correct when it comes to this equation? So to check, I'm just going to test the origin, the 0, 0 point. If I plug 0, 0 into this equation, I get 0 for y is less than or equal to negative 2 times 0 plus 1. I get 0 is less than or equal to 1. So I get a statement that's true when I test 0, 0. So I should be shading the 0, 0 side. So this graph looks like a graph of equation A. So this should be equation A. And then you're just going to keep doing the rest of these. Let's look at B real quick. This is already, so I guess we could start with the ones that are already solved for. I guess this is the only one that's solved for Y. Goes through the point 0, 2, which neither of these go through. 0, 2 is right here. 0, 2 is right here. So B is neither one of those. Let's see. If I subtract 2 from both sides, I get x minus 2 is less than or equal to y, right? This equation here. And if I want, I can just switch the entire equation around. So I'm just going to put the y first and have the inequality still pointed towards the y. This is x minus 2. So now this is going to go through the point 0, negative 2 and have a slope of 1. This goes through 0, negative 2, and this goes through 0, negative 2. This is shaded below. They both have a slope of 1. This is shaded below and this is shaded above. So this is one of these is the graph of this equation. We just have to figure out which one it is. So if I test 0, 0, I plug in 0 for y, 0 for x. I get 0 is less than or equal to 0 minus 2. I get 0 is less than or equal to negative 2. 0 is not less than negative 2. This is false. So when I use the point 0, 0, I get a false statement. So I shouldn't be shading towards 0, 0. So this equation, but I'm shading away from 0, 0. It looks like this first graph is the graph of equation C. And then it's a matter of just finding the only other equation, let's see, that goes through negative 2 and has a slope of 1. So it's not going to be this because you have to have a y-intercept of negative 2. So you'd have to have a 2 all by itself. This has a 2 with the x and a 1. This has a 2 with the y and a 1. So it's one of these two. So let's see, this bottom one here, y is greater than x minus 2. Oh, well, there you go. Our equation here was y is less than x minus 2, and that gave us this graph. So y is greater than x minus 2, that's going to be this graph. So really my only piece of advice is you have to kind of like get every single equation into this form to determine which one matches up with each graph. So the answers would be C, G, and A.